Hello everyone. Today we are going to see the experiment number 9. The experiment title is control an LED using mobile app via ESP32. So this ESP32 previously we conducted two experiment. The pinout diagram everything explained in previous video. The objective of experiment is to control LED connected to an ESP32 board using mobile application, which enables wireless control via Bluetooth using platform like Blynk. So background theory of this experiment is it is IoT control via mobile. ESP32 we are using, that is Wi-Fi. It is built-in Wi-Fi and Bluetooth capabilities that which can host or connect to server, allowing remote access to connected device. A mobile app sends commands to ESP32, which controls LED accordingly. So input we are getting from mobile app to ESP32. ESP32 based on the coding which control the LED. Platform for mobile ESP32 control is we are using Blynk IoT platform. So we are using ESP32 web server. For this component required is ESP32 dev board, Wi-Fi module, LED, resistor 220 ohm, breadboard, jumper wire, smartphone, Android, iOS, Blynk IoT app installed from Play Store into my mobile. So finally, Arduino IDE with ESP32 board installed. Setting up Blynk IoT new platform. So visit this particular link, sign up and create new template, add one virtual pin switch we'd get. Create a device Blynk web dashboard, choose template created, note the authorized token, add one switch we get, assign virtual pin V0. So mobile app, install Blynk IoT app Google Play Store, login into same account, add a switch we get, link switch to virtual pin V0. So connection is simple. This connection previously we have seen. So in breadboard, first you connect LED. So LED anode with the general purpose input output pin 2 in ESP32. Then cathode of LED, you can through 220 ohm, you ground with the ESP32. So this code, it is there. So this is the code for this particular experiment. Here I am giving my Wi-Fi ID, Wi-Fi password I am giving here. Again, coming to the procedure, make the hardware connection in the breadboard ESP32 through upload the code ESP32 using Arduino IDE. Open serial monitor to confirm Wi-Fi connection. Open Blynk app, tap switch, LED should turn on or off. So observe LED toggle on physical board in sync with the app. So observation table, the whenever mobile switch on means the light switch on, LED on. Whenever switch off, LED is off. This is what observation. So expected output is when the switch in the Blynk app is turned on, LED lights up. When turned off, LED goes off. The result is LED was successfully controlled using mobile app connected to ESP32 via Wi-Fi using Blynk IoT platform.